I've been thinking.
Topic of presentation, right? So we have selected 3 groups and 3 topics. So first group is your name? Loudly. Your name? Loud. So your topic is different types of signals. Okay. So first group, please start your presentation.
Good morning and good morning everyone. My name is Indranil and today I am going to present you the most interesting topic which is different types of signal. It is presented by me, Indranil, Gopika and Roshmita Roy. At the very first introduction of different types of signal. A signal is a function that conveys information used in electrical engineering, communication and system. It can be continuous or discrete on time and amplitude. And these types of it is covered state. These types cover state, ramp and gate, sinusoidal, square, impulse and triangular signals.
Go to the next slide.
Second is state signal. State signals is a signal that jumps from 0 to 1. It abruptly in specific time, usually t equals to 0. And the mathematical expression is ut equals to 0 when t less than 0 and 1 when t greater than equals to 0. While ut is the unit step signal and it is used basically input for system testing, switching operations in circuits. The second ramp signal, which is increases linearly with time after t equals to 0. It is the ramp signal mathematical expression r equals to t dot bracket t, where r is the ramp signal and ut is a unit step signal. The basic relation between ramp signal and step signal is ramp signal equals to the integral form of step signal, and it is using modeling, relearning, increasing input precision versus time modeling, and it has a graph of ramp signal. And third, gate signal. Gate signal means finite duration signal that stays 1 for a time interval and 0 elsewhere. And mathematical expression g equals to u minus ut minus capital. This is used basically time limited activation of system parts operation. And it has a graph of gate signal. And the rest part will be discussed if we go to the question.
Here is sinusoidal signal and definition of smooth linear to oscillating signal. Here is the equation of it. Xt is equal to a sin omega t plus phi. Here sinusoidal,
impulse signal, triangular signal,
Pulse,
triangular.
triangular, right, that's five types. So, do you know these different types of signals? What is the application of these signals? I may be confined to step signal or ramp signal. So, there are different types of signals, and whatever may be the signal, we have got different types of card on the basis of the nature of the signal, right? And each and every signal depends on the time. Basically, function of time. So if you are not able to describe the signal in a particular range, then you are not able to explain the signal, right? You are not able to get the graph. So in case of ramp signal, the nature of the car, what is the resemblance of the ramp signal with which one? Which law? Anybody else? Ramp signal follows which law? Basically, the nature of the car. Which law in electrical engineering? Basic law. A line which passes through the only straight line. Which law? Ohm's law. In case of Ohm's law, along x-axis, what is the parameter? In case of Ohm's law, what is the parameter on the x-axis? And along y-axis, so if it is along y-axis I and along y-axis B, then what is the slope of that curve? That is the slope of the curve, and that slope is constant or not? Because resistance is constant, and that R is equal to V by I. Might be in the along x-axis, always time will be there, current will be there, might be voltage will be there, and along y-axis current will be there. If it is reversed, then the slope will give what? I by V, that is admittance. Right? Ohm, that is called ohm. In case of resistance, it is called ohm, and in case of 1 by ohm, that is called ohm. Okay? So these are the signals analytically you can explain. And okay, so come the next group. Thank you so much. Current and voltage response using KCL, KVL, and superposition theorem. So you are Joy Chakraborty, Pritam Pal, Sunil Kumar Bharat. So please start your presentation. Please loud.
Example of superposition theorem also. We have also discussed limitations and applications of KCL, KVL and superposition theorem in circuit analysis. Also summary and references.
So you will focus KCL, KVL, superposition theorem, basic.
So, electric circuits means circuit analysis through some principles and laws through KCL, Kirchhoff's current law, Kirchhoff's voltage law, and KCL, Kirchhoff's current. According to Kirchhoff's current law, the algebraic sum of the total currents through a node in a node that equals to 0. What does mean by algebraic sum? Algebraic sum means by regarding the direction of the currents through the node. Here you can see here is the node, and I1 current is incoming to the node, and I2 incoming, I3 also incoming, and I4 outgoing, and I5 also outgoing. So here summation of I incoming, that means I1 incoming, I2, the I1 plus I2 plus I3, that equals to summation of current out, that means that equals to I1 plus I2 plus I3 equals to I5 plus I4 plus
So your
I5.
convention is you are taking the incoming current
Incoming.
and the outgoing current with respect to one body. So you are adding all the currents and that will give zero. That is the KCL. So what KCL? Okay, take it.
Next, Kirchhoff's voltage KVL. According to Kirchhoff's voltage law, the algebraic sum of all the EMFs and the voltage drops is equals to 0. That means by mathematical from how we do summation of EMFs plus summation of IR, that equals to voltage drop IR means that equals to 0. Here A and B, C, D are the terminals, and E means voltage across A and B point, and here also R resistance are connected to the terminals, and BBC, that means voltage across B and C. It also is here. What is the physical basis? Based on the law of conservation of energy. Next, my name is
So what is the numerical problem?
Incoming current. And 0.5 and 0.6.
Okay, got it. So this is the
Outgoing.
node that speed, and with respect to that node, some currents are incoming, some currents are out. And adding these currents, you are getting zero. Then what is I?
If I know 0.6 ampere.
Okay, that unknown current.
Unknown current.
What the reason?
This is for the KVL example. So the circuit diagram, in the anti-clockwise.
What is I? You are written over here. So I current you have to show there, right?
From anti-clockwise, starting from here, say -10. Then our earth is 5. There is 10 volt, the R1 is 10 volt. Then 5, and then after the 5 volt, then we get the current 1/4
Ampere.
ampere. What is superposition theorem?
First of all, state the superposition theorem.
If linear or parallel circuit, the multi-node current or the voltage across any branch can be calculated by taking the algebraic sum of the values calculated by the taking one source of at a time and the using the other active sources, voltage or current sources, by the internal resistance. First step of the circuit, we find out the active source, which is also voltage or current source. Then taking one active source, and for voltage source we can do the short circuit, and for current source we can use the potential to find out the current. Then on the
So
second,
you are considering that two loops, and this circuit basically contains two sources. DC source, right? One is what is the value of V1? Oh, not numerical value, that's exact circuit. And we are looking for two loops are considered I1 and I2.
and others are the
Others means V2 is,
others which are passive.
if you consider V1, then undercut V2 will be
Transform.
shorted.
Sorry, yeah, sorry. Then find the one to the active source
So,
and
due to
others
contribution
are
of V1, you will determine the current. And after the second step is that when you will consider V2, V1 will be shorted and you will consider the current part 3 for the contribution of V2. So, for V1 and V2, the total current will be added. So this is any numerical problem?
this is like that.
From morning, ma'am. Next slide, I will show.
It's a numerical problem.
Find the current through 3 ohm resistance in superposition. Here, take I1 and I2 are the
Okay,
current.
so initially
But
it was 40 volt I think, right? 40 volt. Initially 40 volt is shorted. So due to contribution of 20 volt, what is the current?
here is the current
904. How can you determine it?
1. First, we need to calculate total resistance 7 ohm. Then from the total current, then current to 3 ohm resistance is defined by I1 IT.
So now determine current I2 using the source 20 volt. Using the source 40 volt, 20 volt will be shorted. So next time. Yeah.
Same process and we have to calculate total resistance. Applying ohms law, you get current. Now, by current division rule, we got the I2 and here 20 volt and 40 volts.
Yeah.
So, by superposition theorem, total current is determined. Indications of applying superposition theorem.
Speaking,
Superposition theorem.
where did you get the term? Is it available in internet? You have to write superposition theorem.
These methods are extensively in circuit design, analysis, and troubleshooting. Superposition is only applicable to linear circuits, independent sources, and nonlinear functions for dependent sources require different analytical approaches. Computation are summary Kirchhoff's current law KCL used in nodal analysis of circuit and KVL using maze or analysis. Superposition theorem simplifies analysis of multi-source linear circuits.
Don't write SPT.
Here are the different standards. Thank you.
Thank you so much, Joy, Pritam, Shubin. So you are so your topic was KCL, KVL, and superposition theorem. So everything is good. Now my question is that using KCL and KVL, you are able to determine the current and voltage. Using KCL, nodal analysis, you will be able to determine the current. Using KVL, partial potential, you will be able to determine the potential drop across any resistance. So if you are able to determine the current using KCL and KVL, what is the utility of superposition theorem and other theorem? So first of all, tell me how many theorems you know. One is superposition. Number two is derivative. Number three is Norton's theorem. Number four, Riemann theorem, maximum power transfer theorem, Delign's theorem. Different theorems are there. So I think you have noticed that in case of Riemann theorem, the structure is like this. This parallel, source and resistor. So on the basis of the structure of the circuit, the theorem will be applicable, right? Yeah? Thank you. So this is the third book. Your topic is different types of relay signal. So first das Pratishthambu in the Sritika resource. So you are requesting to start your presentation. Start.
Good morning, ma'am. Good morning, my friends. Today we are talking about the topic different types of delayed signals. Here are our members.
So you have to keep a gap. Okay, continue.
Introduction says that signal delay refers to
Go to
the
the previous slide. Read out.
context. Here we are talking about what is signal delay and how it affects the circuits, the signals. Then we have the shifted or delayed step signal. Like the different types of signals are there, and the delay, the representation, the graph representation, the mathematical representation, all are dependent. First we have shifted or delayed step signal. Second, there are delayed gate signal. Then we have shifted or delayed ramp signal. Fifth, shifted or delayed impulse signal. Sixth is delayed stopping signal. Then
So 5 signals you will explain, right? Okay, go to the next slide.
first
The font size will be definitely will be bigger, right?
So what is signal delay? Signal delay refers to the infinite time an electrical signal takes to propagate from its input point to its output point, output destination in a circuit. This delay is inherent characteristics influenced by the physical properties of the components, the materials used, and the overall circuit architecture. Primarily due to the physical properties of the components like capacitance, inductance, and the circuit's layout, the trace length or the dielectric material. Here we will learn about the different types of delayed signals we can receive in a circuit. First we have shifted or delayed step signal. So a delayed step signal, also known as shifted unit step signal, is a variation of standard unit step signal, step function, where an abrupt change of a constant value occurs to a specific time t instead of at time t equals to 0, which means in unit step function, the function should start from here, from t, this is t. But in this delayed step signal, it is starting from a certain distance, and this is capital T. We are representing this as capital T. Now mathematical representation says that in step signal, it says ft equals to ut. The mathematical representation of the delayed step signal will be ft equals to u small t minus capital T, which means the initial and minus the shifted t. Ft equals to 1 when t less than equals to greater than equals to 10, and ft equals to 0 when t less than equals to less than when it starts the signal starts. According to the diagram, the equation
The signal will start from t is equal to capital, and before that it will have the value 0, right? Because it is shifted, and in case of not shifted, that signal will start from 0. There will be no time gap. So this is the difference between the delayed or shifted and the normal signal. Okay, next slide.
now
Okay, now come continue.
Good morning, ma'am. So I will discuss about delayed signal, delayed gate signal. So we will know that delayed gate signal is functionally a control signal that controls other systems, and the normal gate signal's value is output value is either 0 or 1. That means or on and off. And so the delayed gate signal refers to a situation where the output of a logic gate changes sometime after the input signal changes. So that means when I give an input, then the output of the delayed gate signal will be held to some delay time. This delay is called propagation delay and or gate delay. And it is a time that takes for a signal to propagate. That means there 1 to 4 is called a propagation
First signal.
it is a time that takes for a signal to propagate,
Yeah.
through it. And the mathematical signal, mathematical representation is Vt is equal to u small t, that is the full time, minus a, that is the where the output is starting, and minus u is equal to small t minus d. Small t, now small t is the total time, and d is the end of the output of get d. So if we relate the gate signal and the step function or step signal, we can see that from point A, this is a step signal, and this is one step signal, and point B, that also a step signal, but on the opposite side. So this is the clinical representation that Vt is equal to u
So,
t minus
in
a.
a nutshell, basically if you want to get the gate signal, you have to consider two signals, that is two step signals. One will be continued, and if other will be continued, not
But
like that,
opposite.
that will be added, then we get the total gate signal.
When the both amplitude will be same.
Right. Next,
Next will be shifted or delayed ramp signal. So ramp signal basically is a control signal. So it is a test signal that we use ramp signal to test other systems and other delays of other systems. So the shifted ramp signal or delayed ramp signal, also known as shifted ramp function, and it is a variation of standard ramp function where the starting time is shifted to a specific time. There is a t instead of t is equal to 0. So 0 to t is a time delay, and the mathematical representation is a Vt is equal to m is the slope here, and small t minus capital T. Small t is the total time, and capital T is the delay. So where the reaction is starting, and into u small t minus capital T. Here the small t is the total.
wrong form is there any necessity to write a of t minus t? If I write ut minus t, that is sufficient, or you have to write a
Ut minus t is the step function.
ut minus t, that is the state function.
Delay step.
And you have to multiply the slope.
The slope. And this is the you can see that if Vt, you consider Vt as a y
I understand.
and mx. So this is the mathematical representation.
A is a constant value,
Constant value.
right? So a of t minus t is necessity. Is there any necessity? Or a ut minus t is enough? Basically, if it is a plain ramp signal, what will be the equation? Is it kT or a ut? If there is a shifting, then it will be t minus capital T whatever. So my question is that if a is a numerical value, that is constant value, it not depends on the t, it is not a function of t, then you have written over here a t minus t. So is it necessary to write a of t minus t, or I will just simply multiply a with t minus t to get the shifted ramp? Understood my question?
For both delay ramps,
For both you have to write t minus t.
no. It's my fault that because so for both delay ramps and normal ramp signal, even the slope will be same. So slope not equal to right. Okay, next is my fault that I. And the next week I will discuss about
What my question?
the secret of delayed impulse signal. So basically impulse signal is a mathematical function that represents a imaginary value, so imaginary graph of a certain time, that is n here, with an infinite amplitude within a finite area. That is a small area m, or here is the k. So
Shifted, right?
so here I consider t as k for the picture.
Okay, I got it.
The
Next
mathematical.
slide. Next slide.
We will discuss.
I will discuss about delayed sinusoidal signal. A delayed sinusoidal signal is a sinusoidal wave that has been shifted in time. This means the entire waveform is shifted to the later or the left
Okay. Sawtooth.
Sawtooth wave is a kind of waveform where
It's like down, please.
sawtooth wave is a kind of waveform where the waveform rises linearly and drops sharply. But when we use the phrase delayed sawtooth, that means that the waveform doesn't start at the usual time zero. Let's take a very simple example like a normal waveform starting at 0 seconds, but in case of delayed sawtooth signal, it starts a bit later. Here, in this graph, if we notice very clearly that the delayed waveform is representing the delayed sawtooth signal. Here, this graph is starting around 0.5 seconds. So, it is what we want to say by delayed sawtooth signal. Mathematically, delayed sawtooth signal can be represented by a specific formula which is already presented here. The formula is f of t is equal to 2 into t minus td by capital T minus of t minus td by capital T minus of half, where tt is delayed time, capital T is period and small t is time.